the Earth from space is a big part of our job. In addition to many other important functions, the International Space Station serves as a global monitoring and diagnosis station where we can conduct observations across the globe, aimed at understanding and resolving environmental issues we face on our home planet. Let's have a look. The space station offers a unique vantage point for observing the Earth's ecosystems with hands-on and automated cameras and image capture equipment. These tools enable astronauts to both observe and explain what they're witnessing in real time. The image capture equipment on the space station also provides input to personnel back on Earth, working to program the station's automated Earth sensing systems, providing flexibility and an advantage over sensors on unmanned spacecraft and satellites. Scientists and researchers find this especially useful when unexpected natural events such as volcanic eruptions, earthquakes, hurricanes, fires, and other natural disasters like floods occur. Through existing international and interagency partnerships fundamental to the International Space Station, data sharing that can benefit people around the world is facilitated, promoting international collaboration on a range of Earth observation activities. A wide variety of Earth observation equipment can be attached to the space station's exterior, like I did on one of my spacewalks. Several instruments have already been installed, and researchers from around the globe are proposing additional payloads to install. In continuing to use a combination of crew-operated and automated Earth observation payloads, the space station collects crucial data on the global climate, environmental change, and potential hazards to the health of humanity and our home planet. The Window Observational Research Facility, or as we call it, the WRF, provides a highly stable internal mounting platform to hold cameras and sensors. With the WRF, the high-quality optics of the nadir, or the bottom viewing window of the space station, allows us to look straight down onto Earth. Do you want to participate in some of our Earth observation missions? Come join us. Check out the Sally Ride EarthCam website. Go to earthcam.org and follow the instructions to sign up. And have a look at some of the spectacular Earth views from space and see what you can identify. You can also try the activity in the link we provided in the description of this video. Thanks for joining me. See you all next time.
Hi, I'm Sunny Williams, and I'm an astronaut who's lived and worked aboard the International Space Station, an amazing research laboratory that's orbiting the Earth about 250 miles above us. While we're at the space station, we astronauts live and work in a microgravity environment. Do you think the laws of physics will hold up in the space station while experiencing microgravity? Let's check with NASA astronaut Mark Vande Hei on the International Space Station to find out.
Newton's first law of motion says an object at rest tends to stay at rest unless acted on by an outside force. Also, an object in motion tends to stay in motion unless acted on by an outside force, like my finger.
Let's look at this from another angle. Over time, the International Space Station slows down from experiencing a very small amount of drag, or force, from a tiny amount of atomic oxygen in space. This is like the force you feel from the air if you stick your hand out of a moving car. Because of this, the space station does what we call a reboost. A reboost uses rocket engines to put a force on the space station. This allows it to speed up just a little to remain in orbit around the Earth. Let's join NASA astronaut Jeff Williams to check out what happens to the objects inside the space station when it begins.
Now, the way I'm going to demonstrate the acceleration that comes during the reboost is by using this camera. 800 millimeter lens, so it's pretty massive actually. And you can see I can float it here, and there's no reboost going on right now, so the camera's not going to go anywhere. It's just going to slowly drift due to the ventilation, or if I put any velocity into it, it'll drift out of the scene. But I'm going to try to hold it here steady, and you can see that it stays very steady. There's my camera. I'm setting it up for ignition. There it goes. It actually came a little bit early. Now,